Hello everyone, I'm Xiaogang Hao. In the previous lesson, we emphasized the concept of modular in great detail. Now let's take a look at the folder hierarchy of this project, and then the engine's project folder hierarchy. First, has anyone ever done something like deleting files from the C drive? I did that when I was a kid, and it caused a lot of trouble. Actually, for the engine, it's the same as for the project. Some folders can be deleted, while others must never be deleted. Deleting them will cause many problems. So in this case, actually, here, to discuss this architecture, I highly recommend teacher does those. Inside UE4, it should be UE5 now. That doesn't matter. It's dozens of articles. Should be a must read. For any Unreal programmer, must watch. Only after you watch it will you have some understanding and reflection on the entire gameplay architecture. Only then will you have some understanding. If you don't watch it, you basically won't find a job. That's how it is. And I myself made a 10-episode video interpreting the first 10 chapters of Inside UE4 EU5. You can also search on Bilibili. It's also on my personal channel. So first, for this course, the project file folder structure, we first create a project. This is relatively simple. Everyone must have played with blueprints and such. Let's just choose games, then select white box, then choose this blueprint, then just give it a name. That's it. Then we get this folder. It looks like this. Pretty simple. If you run it, there should be the save folder, then intermediate, DerivedDataCache, gitignore, content, config. Then if we create for this UEC++ project, if you select C++ here, then it will create a hierarchy structure as follows. Because what we created is how wide. If you are in a development project, you will definitely use plugins. Then this place will have some PICE directory. There might also be some build directories, right? Okay, so here, let's review again for everyone. Review RUPX file. Okay, so first let's open one. Find our uproject, then find local. Go down for should use CP. Let's just look at it. We'll just open it with OS. Okay, let's talk about this again. This is actually to talk about this. Where should we look directly? Look at this thing. Take a look. Let me check here. See if I've released it. There is a project. This Creeper thing. It can let us explain within this uplic or module what each of them is used for. Let me find it for everyone. I took a look here. We will put it on the next slide. This slide is still on this project engine. In this basic understanding section, the next slide will be about coding. Let me arrange this part here. Sorry, wait a moment. Let's go back here. Then we won't go into this uproject. Let's continue looking below. This part is very important. I will explain this feature to you. It is this version switching. For example, let me demonstrate it. This way, we can switch to the source code version. How do we switch? I clicked the wrong spot here. Let's cancel it. There is a switch here. You will see this below. This is our source code version of the engine. Okay, let's click cancel. So the main points here, that is under normal circumstances. Under our project save directory, barrows and intermediate can both be deleted. This cell general image can also be deleted, and this VS can be deleted. VS config can also be deleted. Then this delicate cache can also be deleted. So let me demonstrate. I can actually just delete this. Delete this, delete this, delete. Then we must base it on the actual situation. And if there is a build can sometimes also be deleted. I'm very sure about this part. I deleted it without any issues. So then at this point, if we click once more, this entity1, this source, you must not delete it, right? It just appears. If you run it again, then there's no problem. And when you package it, at this point, emphasize one thing. That is, when you send the project to others, don't send these things over. Because these things are actually very large. This one is okay, only about 20-something megabytes. If it's C++, you just bang it and send this thing to someone. Right, that doesn't make sense. It's clearly just a project of a few hundred megabytes. This hasn't been compiled yet. After I compile it like this, it will become very large. Let's just compile it briefly for now. because after I regenerated the OS project, then you will find that we are only covering the basic structure now. We'll go into the specifics in the next chapter. Okay, it needs to scan this area. It probably needs to scan this area. It takes quite a while to scan this area. Probably right over 50,000 projects. Let's scan it first. Let's compile it for everyone. Take a look at this size. Okay, then we can know, these files, if they are very important or not important. Then how do we do version management? That is to say, we can use the git log file. To do version management, we can open the git log of our project. Let's randomly open a project. We found getlamp. I have already pasted this file into the document. Everyone can see it in the payment. Here is good. This get log. What it means is, first, we got rid of the VS. We return. It is not needed. Because this is a VS related file, then we don't need this custom file either. This intermediate is not needed. So here we ignore them. As for the writing specification of this get file, here is the relative path, as long as it is under the hierarchy, whether under the plugin hierarchy or under the parent hierarchy, as long as it uses this getload file to unlock downwards, as long as it is these file contents and some ants, we ignore them. These are some VS files. This is the solution file. This is something I will do myself. And this is if you use getleafs. Then these two files should also be ignored, because sometimes the reason these two files are generated is because in VS, if you use getleafs, it hasn't been written into our get. So this is a standard git load file. Similarly, this file as getleafs, it specifies which files are managed in the form of large files. Because these files they cannot be viewed like in Gate to see which code has been modified and which code has not been modified. It is just a single block file, typically UAsset or MAPNA. Asset refers to our assets. Then pack files are DL and lab executable files, debug symbols, and these go without saying. Documentation, PPT, JAP, image, PS. Okay, no problem. Okay, so actually this part is to tell you need to do a version ignore. It's easy to explain. We'll skip this part. And this part provides a Lyra's achievement structure. By comparison, Lyra is more detailed. So before we look at Lyra, let me compile it first. Because my computer is very fast, I won't waste everyone's time. I'll compile it in seconds. Then I'll go find the Lyra project. Let me show you this top-level project structure, what it looks like. Let me explain it to you. Okay, good. This is a Lyra top-level project structure. You can see the same location. Where's build? This build is it. Some things generated during build. You can see some interpolated faces. During the packaging process, if you have built an Android package, it will generate some intermediate files, some batch processing files, etc. Okay, right. And this is config. Don't delete this build folder because sometimes the build, some things in it are quite critical. It has already been compiled here. We'll go back and check later. This is config, right? This part involves config for different platforms. Content, right? This is delicate content specific to the platform. This is an intermediate file. Our UHT will generate many files here. These are some files you see. Let me give you an example here. There might be this example here. We have an object like this. We'll talk about uproject in the next chapter. Click on the file. It won't let me in, right? Let's start it up. This is the file. It is placed in an intermediate folder because it is generated in real time. Don't modify it. It's useless even if you change it. The next time you generate it, it will reset. It's quite possible that this area wasn't scanned. It might be because it hasn't been. Maybe it just wasn't scanned. Then click on it again later. Just know that this file is in the intermediate folder. Take a look. See if you can find it. It's hidden a bit deep. Let's ignore it for now. And this is some platform related stuff you'll see when you open it. So this is code configured for a specific platform. We see configuration code. And this plugin, not the Belarus here, intermediate. If your plot car is a precompiled version, these two things must be uploaded. That is, if your plugin does not have source code and does not support recompilation, then these two things cannot be deleted. But then some people provide the source code, but these two files still cannot be deleted because they have used some resources and did not do dynamic copying. Once you know this, in plugin development, this will be explained in detail to everyone. Okay, this is the save file. Some quite some logs. The key point is the logs. Some crash files. If you crash, there will be a crash in this location. Then we click here, and we can see where the crash occurred. This is after packaging. We trace back to find where the crash happened. A very important component called a dump. We will elaborate on this in a UEC chapter. Okay, so this is the log, just like the logs we see in the editor. No problem at all. The most important things are crash and logs, and sometimes we call the engine's automatic screenshots. There will be some print shots here. This is the engine source code. We'll explain it to you later. Okay, so overall, this top level project is like this. Alright, let's directly look at this mind map. Can everyone see it clearly? If you can't see clearly, I'll just look at ours directly. This asset we created. Let's take a look at this project directory. Okay. And we were just telling him to look at this. How big it is. We've already executed it once. Alright, let's just look at this. 58 megabytes, that's fine. But you just look at this. 10.020 gigabytes. If you don't delete it, and you send this to someone else, this will immediately make them question your professionalism. I'm telling you. So that's why this thing. Others might not tell you this, but mark you in their hearts. Yes, so this is about professionalism. That's why this chapter is so necessary. This one can't be open. Let me check. Can't open it? Then I'll search for it. Still, let me find it for everyone, so I can feel at ease every day. Searching now. Ah, found it. Look at his directory. Can we open the file location? Hey, see that intermediate build? 1640, Android editor, Ion C, then XJ, CPP, then UHT, then this header file is generated. This is what we generate. Don't look at how little we have here. But these things are our core reflection information. It helps you generate a lot of things. That's why you can play around in Blueprint. This Unreal Engine, it's that simple. Okay, this is UBD and UHT, the mess they made for us. Then we go back to this project. Let's take a look here. This Binaries stores some custom ones. These files are perfectly fine in the project. Binaries is it. The Win 6.4 platform, there are some DLs, these module rules, this target's goal, these debug symbols and such. These might be some tools. No need to worry about this. Okay, then our engine's banner-wise is very important. We will discuss this in the video in the next section. Okay, this config. For config, we will briefly mention this part because the engine has many configurations. You often modify some configurations in our engine, right? These configurations are mapped to IINI files and then mapped here. Then the configurations here will override the engine's default configurations. This is a project-based configuration, and its configuration had several layers. The layers override each other. You can understand it as the engine overriding the project. After packaging, it overrides before packaging. Then the platform overrides the general. That's the guiding principle, specifically which overrides which. Then insert the document. That is, we clarify the idea. Then it will be very clear when we look at it. Let's just click on one. Look at project lem1. This corresponds to our content in the overview. Let me expand it a bit for you. We'll use the simplest one. Actually, you can see it here. 2. Look, isn't there? Default engine, default game, default input. These are some default outputs. Look at this. Mouse looks very familiar, doesn't it? It's this mouse, right? Let's mainly look at the engine. This is the default map. Open world. Actually, look at some of these configurations here. I'm not sure when you were using blueprints whether this was explained in detail, but I should cover it. Look at these configurations. In the end, they will be exported through these and inserted out. How are these configurations written? Very simple. Using the developer setting class. You can do it right here, like a plugin. Write out your configuration. Of course, I wrote one. Shogun's Developer 13. You can configure some information in it. I'll give you some plugin introductions. This is called embedding into the project. To do these things, you say, right, no problem at all. So this configuration, this file is very important. It cannot be moved. Content is our blueprint. Right, there's nothing much to say about .2. Our content is in this place, this directory. But there is one detail to note. In the cinematic, it likes to be called game. Do you see that? It likes to be called game. This is very important when doing root. Very important. Replace this path yourself. We'll talk about it later. Yeah, Lurdy is about platform-specific technologies. We can delete it. Sometimes you don't need to worry about it. In intermediate, there are some intermediate files, some pre-generated files, and some registry files, etc. Printful is some platform code. We'll explain it in Lyra. The key point is this plugin. Plugins are actually very similar to project, but it's a U plugin, right? This is a uproject and the same by list. Intermediate configurator resource. Note this resource. Our plugin icon is placed here. We can take a look. Look. Here, let's open Lyra. Let's see if he has placed the plugin icon. Let's just click on one. See, he hasn't placed it. Actually, this is our default icon. After you change this icon, just make one the same size as it. Just match its pixel size. See, you make one 128 times 128. You change it. And then in our place like this, it will be changed, right? So this is still very important. Then the source code, third party. Note that your pie chart has two writing styles. The standard writing style must be written in the third party area. If it's not the standard format, you can directly follow your plugin, coupled together. If you want to sell on the Unreal Engine marketplace, you must follow the third party standard format for extension developers. How exactly to write it will be explained later. You can click to take a look. I can open one for you to see. Just a quick glance, because here there isn't that much time to explain in detail right here, since it will be covered later. Because this tutorial is a very detailed one, clicked wrong. You can see we are now going to train and fly this project. You can also get mine on GitHub. This is a free trial version, free for everyone. Third party, mode public, no problem. Provided, no problem. See, this is a third party way of writing. Then this place does not include third party libraries. Then let me show you one with third party libraries. This way, you'll have a better understanding in your mind. So find the Wake-up project. Wake-up includes local ones as well. Let's find this same one. Blank. Third party. See? Exclusive. See? This is the third party resource. This is the content inside the module. What does smallest compilation unit mean? It's right here. Okay, so this gamma feature is quite special. We won't go into detail here. You can know about gamma feature. We can see Lyra, gamma feature. And this depends on the project content. Created the gamma feature plugin, and this plugin must be placed on the gamma feature. This is its hierarchy. Actually, it's pretty much the same, but in fact, it has a very special asset called JSON. This asset manages the project gamma feature's lifecycle. Okay, so we have finished explaining the architecture of the entire project to everyone. Good. In the next lesson, we will explain the hidden person architecture to everyone. Thank you, everyone.